Hi, I'm Jermaine Chen, and today I'm going to walk you through the experiments on collisions and car crashing. So here's a car on a ramp, and it's going down the ramp and it's going to collide. So today we'll look at concepts like conservation of momentum, conservation of energy, and how these two relate as the coefficient of restitution. So we'll look at three kinds of collisions. Fully elastic collisions, like this, partially inelastic collisions, and fully inelastic collisions. So to set up for today's experiment, first we have the car, and make sure it sits on the ramp well so it can slide up and down. Then make sure that the ramp is raised sufficiently, so if it's too low, put something underneath it so that your car can slide down with some ease. The next thing we want to do is position the motion sensor at the top end of the track. So we use a motion sensor, and this is where the sensor is. It looks out at the wall. We put it at the top of the track so that it can look at the car as the car leaves. Now the sensor has a swivel, so make sure you position it well such that it looks square at the car as it goes down. Also, what's important is to make sure that around the track and where the motion sensor is looking at, that there are no big items or bins that would cause reflections. So this is a good time to put your big yellow bins on the floor. So now we've got the motion sensor set up. We need to have it to connect to the Logger Pro. So first of all, you power it up, connect it to the power supply, and then it will wake up. The lights will come on. The next step is to use this cable, and first of all connect to this port over here. Fit it in, like that. And then connect it on to the motion sensor. So now we've got the motion sensor connected to the Logger Pro. Last step is to have this connect to the computer. So using the USB cable, again where this is, pop it in and connect that to the USB port on the other side. So now we've got the Logger Pro hooked up to the computer. The next step is to get the Logger Pro interface. So look for one of the icons here at the bottom. It says Logger Pro. Double click that, open up, and this interface will open up with, if you hooked it up right, you will get three graphs, one for position, for velocity, and for acceleration, all of them as a function of time. So before you start your experiment, make sure you have the correct sampling rate set up for the motion sensor. How we do that is to go to this icon at the top right next to the green button. It says data collection. If you click that, this window comes up, and from here you can change how many samples you want Logger Pro to take per second. In our question, we want 30 samples per second. So now we are about to make a measurement using the motion sensor. So have the car ready on the track. Click collect, which is the green button in the top right corner, and then let go. So now we have got three graphs on the computer. They don't look very much right now, so we need to scale them in So go to the icon with the big A on it and click scale. That would change the scale of the graphs in this way so you can look at it in detail. What's important now is to be able to relate what's on the screen with what went on the track. So in the first graph we see, which is for displacement versus time, we see the car gaining displacement, going down the track until a certain point where the collision happens, and then it starts to bounce back and comes back up the track. So in the top graph, we've seen how displacement and time relates to the position of the car. Are you able to relate the next two graphs for velocity versus time and acceleration versus time to the motion of the car? We're going to make a measurement of an elastic collision. Notice how the curves on the graph relates with the motion of the car on the track during the collision. So to read off the graph, highlight the region that you're interested in, for example this part, then go to the stat button up there, and if you click it, it reads for you different features of the graph. So for the experiment, we need to have 3 different collisions. One with an elastic collision. I'm going to cut that. Put this down. And one with an inelastic collision, and one collision that's in between. And from there we look at the 3 different sorts of coefficient of restitution associated with the 3 collision types. Okay. And an inelastic collision, and from there your job is to work out the coefficient of restitution for each case. So for the second part of today's experiment, we need to use an accelerometer. This is a little black device that has got an arrow marked on it. So make sure you've got the accelerometer fitted in the direction that records the direction of collision you're interested in. So using the accelerometer, fit it to the car, like so, and you can use the rubber band that's provided to tie it down to the car. Again, make sure that the arrow points in the correct direction. So after we've got the accelerometer mounted on the car, we connect the accelerometer to the LabPro. We connect it to channel 1, which is a different channel from what we connected the motion sensor to. So it goes in here, and if it's set up right, open a new experiment on the LabPro interface on the computer, and it should just look like this with one graph just showing acceleration. And when you're ready, you can click collect. So before we start the collision, we need to do 2 things. First, we need to zero the accelerometer by clicking the blue 0 button. Click it and hold the accelerometer still. Like so, you will see the number go to 0 at the bottom. The next thing we need to do is to change the sampling rate. To do that, go to the icon that says data collection. That's the one with the clock. Click it, and then change the sampling rate to 200 times a second. Like so. And then now we're ready to have a collision. So when we're ready to do the collision, make sure the cable is up and not dragging on the table. And then we click collect and let it go down the track. And when do you think the collision took place? So this is the region of the curve we're interested in. So let's highlight it and zoom in using the zoom in button. So this is a plot of acceleration versus time, and the collision has taken place in the region of negative acceleration. We're interested in the maximum acceleration there, the time over which it takes place with the impulse. For the last part of today's experiment, we want you to find a way to reduce the maximum acceleration experienced during the collision. One of the ways you can do that is to increase the duration of the impulse. How do you think you can do this?